Okay, welcome back everyone to Grockit's OGTV. This is the GMAT edition. As hopefully you knew in in the process of navigating to this page, my name's Jim Jacobson. That's me up here. I will be your teacher for today. And we are going through the 12th edition to the guide to the test, page by page, question by question, making sure that we cover everything between the covers. And last time, let's see. Last time I think we finished off with question number 30 on page 275, so we're going to start with question number 31 on page 275. So, question number 31. And as is the case with the data sufficiency section, I like to write down the side of my page, side of your screen here, what each of the answer choices represents in shorthand. So one is that choice, statement 1 is sufficient on its own and statement 2 is insufficient. B is that statement 2 is sufficient and 1 isn't. C is that together they are sufficient but individually are insufficient. D is that either one is sufficient on its own. And then E is that neither one is sufficient on its own or in conjunction with the other ones. So, without further ado, let's get started. So if t denotes the thousandths, there we go, that digit, in the decimal representation of d above, what digit is t? Thousandths. I don't know why I'm having trouble saying it today, but anyway, d equals 0.43 t7. So basically this, t represents this digit. This is what we're trying to figure out, and we're going to find some other information out about t, or d, as it turns out. So statement 1 says if d were rounded to the nearest hundredth, the result would be 0.44. So remember with rounding that if the next digit after the one that you are rounding to, so we're rounding to the, I'll just rewrite it here. So we're rounding to this digit here. If this digit is less than 5, it stays the way it is. If it's greater than or equal to 5, it goes up 1. Since we rounded to the hundredths digit and it became a 4, we know that t is greater than or equal to 5. However, this is a value data sufficiency question, and so with value questions we need one single value for t in this case. And since t is expressed as an inequality here, that it's greater than or equal to 5, there's a whole range of values, 5, 6, 7, 8, 9. So with 5 different values for what t could equal, statement 1 on its own is insufficient. We can cross off answer choices A and D for that reason. Statement number 2, if d were rounded to the nearest thousandth, the result would be 0.436. So again, we have our decimal d here, except this time we are rounding to the digit that actually has t in it. And so if this digit here is less than or equal to 5, it stays whatever it is, it stays t. And if it's greater than or equal to 5, it goes up 1. Since 7 is greater than or equal to 5, t is incremented by one number. And when incremented by 1, it's a 6. So that tells us, of course, that t was itself a 5, and this statement is then sufficient for us to answer the question. We can cross off the together and the neither options, C and E. Statement 2 on its own is sufficient. On to the next column, the last column in this pair of pages, 275, question number 32. So Jerry bought 7 clothing items, including a coat, and the sum of the prices of these items was $365. If there was no sales tax on any clothing item with a price of less than $100 and a 7% sales tax on all other clothing items, what was the total sales tax on the 7 items that Jerry bought? So we know the amount of the sales tax, and we know the number of items that he bought. So it's 7 items, and a 7% tax on items that are, is it $100 or more? No tax on items that are less than $100. Yeah, so greater than or 7% tax on items greater than or equal to $100. In order to figure out exactly how much sales tax Jerry paid, we actually need to know not only that we need to know the number of items, of course, and also we need to know what the prices of those items are, because of course if they're below the $100 price threshold, he pays no tax at all, and so we wouldn't figure out tax in the equation. So it's more complicated, I think, maybe than it looks at first. So statement 1 on its own says the price of the coat was $125. So, you know, we know that part of his, what is it, $365? He spent $365. That tells us that $240, oh, sorry, actually, that I didn't account for the tax on the coat. Anyway, it doesn't even matter. We have one single item in statement 1. One item on its own is not going to be enough to figure out what he paid in tax on all of the items. We don't know how many items were at least $100 and therefore taxable. We just know that one of the items was. So this statement is insufficient. We can get rid of A and D. Statement 2, the average or arithmetic mean price for the 6 items other than the coat was $40. So, so the sum of the other 6 items divided by 6 equals 40. And what that tells us basically is that the sum of the other 6 items was $240. However, just because the average was 40 doesn't mean that each of the other items was 40. It could be that all 6 items were $40 each. You know, they were 40, 40, 40, 40, 40, and 40. They could have just as easily have been 10, 10, 10, 10, 100, 100. In which case, the taxable, the amount that Jerry paid in tax would actually differ. These 2 items would be taxable, whereas none of the items would be taxable if they were $40 each. So we don't know anything about you know, which of these is true, so this statement on its own is insufficient. We can cross off B. We are left with whether these 2 in conjunction are sufficient. Even together, though, even knowing that he spent $125 on one item, that locks in something like this. You know, there's one item that's over $100, but we still don't know what the average or what the actual values are for the remaining things. They could be all sorts of unusual prices. You know, they don't have to all end in 0 or be even multiples of 10. And without knowing what the other prices are, we don't know how many other items were taxable, how many were also over $100 in addition to his coat. So, even in conjunction, the 2 statements are insufficient. What am I thinking? Even in conjunction, the 2 answer choices are insufficient, giving us answer choice E, that neither statement is enough, even together. So, 275, number 33. What was the price at which a merchant sold a certain appliance? So, we need the price. Selling price, I should probably specify that. Selling price of a certain appliance. We don't have any other information in the question stem, so we just have to go right to the statements because we don't have anything else that we can do. The merchant's gross profit on the appliance was 20% of the price at which the merchant sold the appliance. So now we're starting to get some ideas about what our variables are going to be here. So we could say B equals the price that the merchant bought the appliance. We could say S is the price at which the merchant sold the appliance, and yeah, and so then of course the amount that the merchant sold it for minus the amount that the merchant bought it for is going to equal P, and then P we can have equal the profit. I think that's pretty clear. Okay, so the first statement tells us the gross profit on the appliance was 20% of the price that it was sold. So using our variables over here, this tells us that the profit was 20% of the selling price. And so then we can also, do the remaining equation there. We can say that S minus, or the selling price minus the price that the merchant bought it for equals that 0.20S. We can add, subtract 0.2S from both sides. This is an S, not a 5. And add a B to both sides, so we get the price that the merchant bought it for equals 80% of the selling price. However, we actually need the real number for S. So statement 1 on its own, even though we're able to figure out a lot of stuff, we need the real number. And statement 1 doesn't give us any actual dollars, so we can't go any further. So it's not A and it's not D. Let's take a look at statement 2. The price at which the merchant sold the appliance was $50 more than the merchant's cost of the appliance. So using our same variables, we have here that the selling price equals the price that the merchant bought it for plus $50. That's a dollar sign, really. So again, this gives us some information, but because we don't have any information on what the buying price was, again, we're considering statement 2 in isolation. We have 2 variables and only one equation, and with numbers in it. So we don't have enough to determine the price there, so it's not B. We're down once again to the 2 statements together, which is choice C, or neither one is enough. So when we consider the 2 in conjunction, it actually looks a lot better. Because we have a value for B that is in terms of S, we can substitute that into this equation. So S equals 0.80S plus 50. So then, we subtract a 0.8S, 0.2S equals 50, and then, we can solve from there. This is an S. I probably shouldn't have chosen S as a variable. Anyway, so these 2 statements in conjunction then are sufficient, giving us answer choice C as the correct answer. Page 275 still, and now we are on question 34. Okay, so the inside of a rectangular carton is 48 centimeters long, 32 centimeters wide, and 15 centimeters high. The carton is filled to capacity with K identical cylindrical cans of fruit that stand upright in rows and columns, as indicated in the figure above. If the cans are 15 centimeters high, what is the value of K? And so K is the number of cans, because K stands for cans, apparently. Anyway, so I'm going to just kind of reproduce this drawing to the best of my meager abilities, because there's parts of this that matter. So, and then, that keeps going in all directions. So the things that we can figure out from the question before we even hit the statements. One is, the box is 48 by 32 by 15. The cans themselves are 15 high. So they fit exactly into the height of the box. Okay, so this is the length, the width, and the height. The cans are also 15 high, so all we really have to care about is the length and the width of the cans. The cans are cylindrical, so the length and the width are the same. So what we're dealing with here is actually the diameter of the cans, or the radius, either one. Or I suppose if we were given the circumference of the cans, that would also get us where we need to go because of the properties of circles. You get one of those bits of information, you get all of it together. So because these fit in exactly evenly, that's how getting the diameter or radius can get us exactly how many cans will fit in the box. So, yeah, let's start looking at the statements. Statement 1 tells us that each of the cans has a radius of 4 centimeters. Well, that is supremely helpful. So that tells us that the diameter is 8. So every can will be 8, and as it turns out, both the length and the width are divisible by 8. You know, times 6 and times 4. So we could figure out exactly how many cans fit in there. In fact, it's 4 by 6. So statement 1, I should probably have written that in. The radius equals 4, so therefore the diameter equals 8. Statement 1 is sufficient to tell us how many cans will fit in our box. So we can cross off statement 2 alone, as well as the options C and E, which need statement 1 to be insufficient. Let's take a look at what statement 2 says. 6 of the cans fit exactly along the length of the carton. Which, of course, I mean, we have to kind of pretend like we didn't just figure that out from statement 1, but it tells us basically the same information. If 6 cans, we know the length of the carton is 48. If 6 cans fit evenly exactly in that space, then we know that the diameter of each equals 8, giving us exactly the same information that was in statement 1. So, statement 2 also sufficient, allowing us to cross off option A, which is that statement 1 is fine on its own, giving us answer choice D, either statement is sufficient. Last one on page 275. For the system of equations given, what is the value of z? So we have a system of equations here. We have x minus 4 equals z. We have y minus x equals 8. And 8 minus z equals t. I'll just renumber these 1, 2, and 3. So at first glance, this might actually look like it would even be sufficient on its own, but it's important to note that there are actually 4 variables in this question, not just 3. We have x, y, z, and t. With 4 variables, we need 4 distinct equations to solve for any of them, basically. Classic GMAT, it's not really a trick. It's something that gets tested often on the test. So, you know, one of the things to remember is that with when you have more variables than you have equations, you either need additional equations or you can be solving for a relationship between 2 variables. And then you don't need the same number of equations as variables. The other thing worth noting is that the equations do need to be distinct. We couldn't, for example, get something like 2x minus 8 equals 2z. That would not give us any additional information. That's the same thing as equation number 1, just multiplied by 2. The new equations need to give us new information. Let's take a look at statement 1. Statement 1 tells us that x equals 7. So, you know, in this particular case, we would probably and so this is definitely sufficient. We could substitute the value of x equals 7 into equation number 1 here. So 7 minus 4, we'd have a value for z, an actual number. We would take that number and substitute it into both statements 2 and 3, and we would get real numbers for y and t as well. So statement 1 is sufficient. B C, and E are all ruled out. Statement number 2 tells us that t equals 5, and that's not the same as any of the other information that we have. So again, getting a fourth equation, distinct from the 3 that we have, allows us to substitute for all the rest of the equations. We'd start off, of course, by substituting it into equation number 3 up here, so then we could figure out our value for z, and we would be able to go from there. Once we had z, we could go to statement 1, etc. So, statement 2 also sufficient, ruling out statement 1 on its own. Means answer choice D is our correct answer for the day, or for the question anyway. All right, on to page 276 and question number 36. So for all integers n, the function f is defined by that function of n equals a to the n, where a is a constant. What is the value of 1 in that function? So let's get that down. F of n equals a to the n. Right. So in order to have sufficiency here, basically we need to know what a is. That's the answer here, because n is just whatever the number is plugged into the function. We're raising a constant to some power. What is that constant? Only time will tell, and statements, maybe. Okay, so statement number 1. So f of 2 equals 100. So what that tells us is that, a to the n is actually, so that gives us a squared equals 100. An important thing to remember about the GMAT, of course, is that when you are given something like this, there are actually 2 possible values for a. That's the big trick on this question. A itself could equal 10 or negative 10. Each of these numbers squared gives us 100, and we can't tell which one it is. Had we been given something like, a equals the square root of 100, the radical sign always denotes the positive square roots, but that's not what we got. So when you have 2 values in your answer choice for a value question, and that's what it says. It says, what is the value of f of 1? This is insufficient. 2 values is 1 value too many. So it's not A and it's not D. Let's take a look at statement number 2. So this time we have 3, and that equals negative 1,000. So that tells us that a cubed equals negative 1,000. And it's important to note that, and important to remember, the only way you can raise a number to an exponent and get a negative number is if it is a negative number and you're raising it to an odd numbered exponent. 3 is definitely an odd numbered exponent, which means the initial constant must be negative. And in fact, negative 10 times negative 10 is 100, but times a third time times negative 10, that equals negative 1,000. So a equals negative 10, our only value for a, which makes statement 2 sufficient, giving us choice B over C and E. (276), number 37. The selling price of an article is equal to the cost of the article plus the markup. The markup on a certain television set is what % of the selling price? So we'll make S the selling price. We'll make C the cost and M the markup. Whenever possible, it's best, I think, to use variables that resemble things from the actual question so you don't confuse which is your X and which is your Y. So even if you don't go to the trouble of writing out what your things are when you do your practice and when you do the real test, Using familiar looking variables helps you keep track of them. Okay, so this tells us, the initial thing tells us that the selling price equals the cost plus the markup. Let's see what the statements actually give us. So that's 3 variables and 1 equation, which has no numbers in it. So let's see where we can go. The other thing that's important to note, the question is asking the markup on a certain television set is what % of the selling price. So what we're actually solving for is M over S as a %. So it's a little bit different. We're not actually solving for a single variable. So statement 1, the markup on the television set is 25% of the cost. So the markup equals 0.25 C. So then we know that the selling price, using our equation up here from the original question, equals C plus 0.25 C. We can add those together. We get S equals 1.25. So the selling price is 1.25 times the cost. And from there, we can actually solve the rest of the way, because what we're solving for is M over S, not just one of the two. M equals 0.25 C. S equals 1.25 C. And from there, it's 1/5, which is 20%. Of course, as soon as we realized we could solve, we should have just stopped and put a big S here for sufficient and crossed off answer choices B, C, and E. But I wanted to demonstrate how it was sufficient. Okay, statement 2 says the selling price of the television set is $250. So statement 2 tells us that S equals $250. But since we actually were trying to solve for the value of M over S, we would have needed the value of M, and the only way we could get to M from the information we were given in the original question is if we also had C. We didn't get that in statement 2, or statement 2 plus the original question, so this is insufficient. So we can cross off D and circle or click on answer choice A. Statement 1 alone is sufficient. Okay, 276, number 38. So if P sub 1 and P sub 2 are the populations, and R sub 1 and R sub 2 are the numbers of representatives of District 1 and District 2, respectively, the ratio of the population to the number of representatives is greater for which of the two districts? So we are comparing P1 over R1 to P2 over R2. And without any further information about these guys, we can't do anything else. So we have to hit the statements. Statement 1 says that P1 is greater than P2. It's good to know, but without knowing the denominators here, so for example, P1 is greater than P2, so P1 could be 3 and P2 could be 1. But if R1 is 10 and R2 is 3, well, I made this a little bit closer than I meant to, but 1/3 is still more than 0.333 is more than 0.3. So just having a greater numerator on its own is not enough to make a comparison between these two ratios. So statement 1 is insufficient. Cross off A and D. Statement 2 tells us that R2 is greater than R1. And it works the same way. Just because the denominator is bigger, normally with fractions, a larger denominator means it's a smaller fraction, but without knowing the numerator, it doesn't really help us. We need both the P's and the R's in order to solve this, at least potentially. So it's not statement 2 on its own. In conjunction, what we have is that, using our original things here, the numerator of the first fraction is greater than the first one, and the denominator of the first fraction is less than the second one. And remember, those are the two ways that you can make a fraction bigger. Larger numerator with smaller denominator, just to compare, larger numerator, you could have 2/3, and then if you had a smaller denominator and a smaller numerator and a larger denominator, you'd get something like 1/10, and 2/3 is clearly greater than 1/10. That's also why, as denominators get larger, the fraction gets smaller, which is why when you raise fractions that are less than 1 to higher powers, the fraction actually gets to be smaller. Anyway, so the two statements in conjunction give us a clear relationship between the two ratios. The first fraction is larger than the second fraction, and the two statements together are sufficient. Okay. 276, number 39. In a random sample of 80 adults, how many are college graduates? Good question. There's no other information in the question stem, so we really just have to hit the statements. Statement number 1. In the sample, the number of adults who are not college graduates is 3 times the number who are college graduates. So if we make C college graduates, and then the number who are not college graduates are 3 times that, those two numbers together equal that random sample of 80 adults. So that, we could solve the rest of the way for C equals 80, C equals 20. Clearly, statement 1 is sufficient on its own, so we can cross off B, C, and E. Let's take a look at statement 2. In the sample, the number of adults who are not college graduates is 40 more than the number who are college graduates. So it looks like we can get something similar. So we have the number of college graduates plus the number who are not college graduates. Here we would represent by that number plus 40 because they are 40 more than C, but we have to remember to account for the C the second time. That also equals our sample of 80. So 2C plus 40 equals 80. 2C equals 40 and C equals 20. Again, and you shouldn't end up with different answers. When the statements are sufficient, if you were to do the math, you will arrive at the same answer. If you don't, that's when it's time to frown, maybe cry. No, don't cry, I'm kidding, don't do that. It's time to rethink your approach to the statements. Anyway, the two statements each on their own are sufficient. Answer choice D. Okay, 276, number 40. So the table above shows the distance in kilometers by the most direct route between any two of the 4 cities R, S, T, and U. For example, the distance between city R and city U is 62 kilometers. What is the value of X? I don't think I'm going to rewrite out this whole chart. I don't think I need it. You all have the book in front of you, at least in theory. I think we shall just go from here. What it does tell us, though, is so we have 2 different variables in that table above. There's y and x, and then we have the other values inserted in there. It's asking us what the value of x is. And from looking at the chart, there's nothing that indicates that the distances between the cities are in some way proportional. Do you see what I'm saying? Like, there's not clearly a progression in the distances between the cities. Just looking across the bottom row, which is one of the rows that has all the numbers in it. R to U is 62, S to U is 75, T to U is 69. There's not really a clear sense there of there's 7 miles between the one and 6 miles between the second one, so there's not a pattern. What that means for us is that getting y alone, note that we have both y and x, getting y on its own won't help us get x unless we're given some other information about the relationship of y and x. So let's take a look at the statements. So by the most direct route, the distance between S and T is twice the distance between S and R. So ST is 56, and SR is Y. And we find out from this one that ST is twice the distance of SR. So 56 equals 2y. So that allows us to solve for y, y equals 28. But since we don't have any relationship with x in this one, which is what we're solving for, statement 1 doesn't give us anything. We can also cross off answer choice D, which requires statement 1 to be sufficient. Let's take a look at statement 2. By the most direct route, the distance between T and U is 1.5 times the distance between R and T. So TU is 69, and RT is X. X is what we're after. So, and this tells us that TU equals 1.5 times RT. So 69 equals 1.5 times X. And from there, we could divide both sides by 1.5, and we would solve for X. Statement 2 is sufficient. We can cross off C and E and confirm that statement 2 alone is enough to answer our question. And we can move on to the next column. Still page 276, of course. Question number 41. What is the value of the 2-digit integer x? Well, so we know we have 2 digits, but we don't have anything else about it, so let's just look into the statements here. Statement 1, the sum of the 2 digits is 3. So if we make t the tens digit and u the units digit, we know that t plus u equals 3. There aren't that many numbers that add together to give you 3. Basically, you have 1 plus 2 and 0 plus 3. And we have a 2-digit number. So our choices for this number are 12, 21, 3, and 30. However, nobody would really consider 0, 3 a 2-digit number because the 0 is meaningless. So there are actually 3 possible values for our 2-digit number x. However, this is a value question. We need one specific value. Since we have 3 values, it's not enough. So statement 1 is insufficient. We cross off A and D. Statement 2, x is divisible by 3. Wow. Well, so, that x divided by 3 is an integer. I am not going to list all the 2-digit numbers that are divisible by 3. There's a lot of them, and, anything from 12 to 99. In fact, that's the lowest one to the highest one. I guess I got lucky in coming up with that. So, there's so many values here, it can't be statement 2 on its own. We cross off B. What about in conjunction? So, statement 1 narrowed it down to 3 choices, where their digits added up to 3. And we also need it to be divisible by 3, but if we just look at the numbers we had in statement 1, 12, 21, and 30 are all divisible by 3 in addition to the digits adding up to 3. So we still haven't narrowed it down beyond those 3. Even in conjunction, our 2 statements are still insufficient. We can cross off C and select E. All right, so page 276, number 42. So the figure above shows the circular cross-section of a concrete water pipe. If the inside radius of the pipe is r feet, is that r? Yeah. And the outside radius of the pipe is t feet, what is the value of r? So may as well draw the picture. So from the center to here is r, and the center to here is t. So each of those is the radius of a different circle. Obviously my picture doesn't look exactly like the one in the book, but that's the way it is. I'm not that great at drawing circles. Anyway, so we have the two radii, radiuses, either one would be correct, and we need to figure out what the value of r is. It's a value question, so we need one single value of r, but there isn't any figuring really that we can do from this, so we just have to hit the statements. So statement 1, the ratio of t minus r to r is 0.15, and t minus r is equal to 0.3 foot, 3/10 of a foot. So it tells us that the ratio of t minus r to r, excuse me, is 0.15, and it tells us that t minus r equals 0.3. We could substitute t minus r, this value for t minus r, into that first equation, so we get 0.3 over r is 0.15. We can multiply both sides by r and divide both sides by 0.15, and so we'll get r equals 0.30 over 0.15. Then becomes straight up arithmetic, r equals 2. And that's what the question was asking. What is the value of r? We have one single value, so statement 1 is sufficient. We can cross off B, C, and E. Again, it is worth your while to cross off these things so that if statement 2 in this case were just so mystifying that we couldn't make heads or tails of it, we still have a 50% chance of guessing. We know which answer choices we've eliminated. Hopefully that doesn't happen though, because that'd be sort of embarrassing for me. Anyway, the area of the concrete in the cross section is 1.29 pi square feet. So 1.29 pi. That area of the cross section would be the area of the outer circle minus the area of the inner circle. The area of the outer circle would be pi times the radius of that outer circle, which is t squared. And we would subtract from it the radius of the inner circle, which would be pi times r squared equals that 1.29 pi. We can divide all of this by pi to make it a little bit easier. We end up with t squared minus r squared equals 1.29. Now beyond this, we have two variables and one single equation. And there's multiple values for r squared and t squared, where the two numbers, when subtracted together, give you 1.29, especially since we can use fractions, we can use decimals with any number of decimal places basically. So because there's so many values, and certainly not one distinct value for t squared minus r squared equals 1.29, statement number 2 is insufficient, allowing us to eliminate answer choice D with confidence and circle answer choice A. Okay, a couple more to do before the end of the session. Page 276, number 43. Okay. So what is the tenths digit in the decimal representation of a certain number? We need the tenths digit. You may remember that, and a decimal x, y, z. The tenths one is the first one after the decimal point. So we need to know something about what this number is. So statement 1 tells us the number is less than 1/3. So, 1/3, you may remember, is 0.33333 ... So our fraction is then anything, or our decimal is anything less than that, which includes then numbers that, it could just be 0.3, 0.3000. 0.3 is less than 0.33333 repeating, so it could be 0.3. It could also start with 0.2 something, 0.1, or 0.0, 5, 6, 7, who knows. So there are 4 different tenths digits that are possible for a number with a decimal representation less than that of 1/3. We need a single value for the tenths digit, so this is not going to be sufficient for our purposes. It's not A and it's not D. Statement number 2, the number is greater than 1/4. 1/4 equals 0.25 as a decimal. That leaves us, of course, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9 as tenths digits for a fraction greater than 0.25. In fact, it even gives us 0.2 because it could, for example, our fraction could be 0.26, and that is greater than 1/4, and so this is way too many values for us. Statement 2 is not sufficient on its own, so now we need to consult the two together. So when you consult two statements like this with multiple values in the answer choices, you look for the overlap. If the overlap is a single value, you win, or it's sufficient. And if it's not a single value, you don't, or it's not sufficient. In this particular case, it's still possible for it to be 0.2 or 0.3, even with the two statements in conjunction, where it's less than 1/3 and greater than 1/4. So even in conjunction, the two statements are not sufficient, giving us answer choice E. Okay, last one for this session, page 276, number 44. So robots X, Y, and Z each assemble components at their respective constant rates. If R sub X is the ratio of robot X's constant rate to robot Z's constant rate, and R sub Y is the ratio of robot Y's constant rate to robot Z's constant rate, is robot Z's constant rate the greatest of the three? Wow. Okay, so we have robots X, Y, and Z. And we have our X is X over Y, and our Y is, no, I didn't even do that right. This is X, or I'm just going to rewrite it. X over Z, our Y is Y over Z. Okay, so of course, without knowing any other information about X, Y, Z, or their respective ratios, we aren't able to determine anything else. But we want to know whether Z is the greatest. Let's take a look at the statements. Statement 1, we know that our X is less than our Y. So what that means is that X over Z is less than Y over Z. We could multiply both sides times Z. They're all constant rates, so we know we're not multiplying by a negative number. Therefore, X is less than Y. Now, that's useful, but we need to know about Z, and Z is completely out of this equation now. So statement 1 is insufficient for us to determine whether Z is the greatest of them, so we can cross off answer choice A. We can also cross off answer choice D, which required statement 1 to be sufficient. Statement 2, we find out that RY is less than 1. So that alone, and remember RY is y over z, and that's less than 1. If we multiply both sides times z again, we end up with y is less than z. Again, that alone is not enough to tell us whether z is the greatest because x is not in the picture at all. So that can't be sufficient. We need to know z's relationship to both x and y. So totally not enough. We can cross off b. Now we have to consult the two together. We have x is less than y and y is less than z, leaving us with the straightforward inequality x being less than y, which is in turn less than z, which tells us that absolutely z is the greatest. Z wins. The z robot has the greatest rate. So together, the two statements are sufficient to identify z as the greatest. Answer choice C is the correct one. Okay, and that is the promised number of questions for the day. Thank you for watching this broadcast. My name's Jim Jacobson. You've been watching Grockit's OGTV GMAT edition. We're going through the 12th edition of the guide, and we are, I'd say a little bit less than halfway through the data sufficiency section. Of course, you can get back and look at the earlier broadcasts, I believe. And of course, I would love it if you stayed in touch and tuned in tomorrow when we will pick up where we left off. We'll pick up with question number 45 on page 276. So I hope to see you then.